गुरुर्ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरा गुरुसाक्षात् परब्रह्म तस्मै श्री गुरवे नमः.
Hello everyone. As the next part of the software concepts, let us try to understand the next system software, type of system software, that is operating system. As I have already told you or mentioned in the earlier session, that the operating system will act as an interface between the user and the hardware. It is going to act as a mediator between the user and the hardware. If you can see the diagram there are 3 or 4 users and you have an interface called operating system, and then you have the hardware part called CPU, RAM, etc. Let us not worry about those components in the hardware part. Okay. Users are there to interact with the hardware. You can ask me a question, why do you want to interact with the hardware? We need to talk to the CPU. We need to give the instruction to the CPU to perform some work. Straight away, directly, you cannot interact with the CPU. You need to have a mediator. You need to have an interpreter. You need to have a translator basically, or you need to have an interface. This operating system will act as the interface or a mediator between the user and the hardware. It's a system software. It's a type of system software. This software, especially the operating system, controls and coordinates all the activities between the user and the hardware, user and the CPU, user and the hardware. Hardware need not be the CPU, need not be only the random access memory. It can be any resource connected to the system. Keyboard can be there. Keyboard is a hardware. Video is a hardware. All other devices which are connected to the system are called hardware, which you can touch and feel. To interact with those hardware components, you need to have the interface called the operating system. Next, you need to know in detail about the operating system. See, once you switch on the system is a dead machine, as I have already told you. Once you switch on the system, straight away the computer cannot start working and respond to the users. Okay. Now what is to be done for that? Now you have one part of the operating system called BIOS, which I have told you earlier, mentioned earlier, about the read-only memory, contents of read-only memory, firmware, isn't it? That gets automatically loaded from the read-only memory to main memory. Main memory is random access memory. Automatically it gets loaded when you switch on the system, when you give the power to the system. See, giving the power to the system is like blood circulation. That is not sufficient for the system to start working and responding to the user. So you need to start or prepare the brain to start working, isn't it? That starting of that brain activities is done by the BIOS or basic input output system, which is present in read-only memory called firmware. Automatically it gets loaded from read-only memory to random access memory. It checks for the devices and their proper connections, and then it loads the operating system from the secondary memory. Normally operating system will be present in the secondary memory to the main memory, and the system is ready to use. So you have the computer hardware there, operating system there, system and application programs are there, and then users are there. Okay? Maybe one is the text editor, one is a compiler, one is an assembler, one is another software. Can be any software for that matter. Okay. Now, Some of the examples for the operating system are DOS, disk operating system, the oldest operating system. The old operating system is called the disk operating system. Still it is there. On that only the Windows environment is created. Okay, Windows environment is created on that only. Windows environment it is just the user interface. Okay, user interface, easy user interface. DOS, actually it is the character or command based interface. So we need to remember the command. So later on we will discuss those things later. MS-DOS is one, Unix is another one, Linux is another operating system. Like that, they are all character based operating systems. But of course Linux is a hybrid, both character based and also the graphical based operating system. Win95 is there, Win98 is there, Windows 95, Windows 98, Windows 2000, XP, 7, 8, Android, the one which you are executing on our mobiles, Mac operating system, iOS, there are so many operating systems available now. Next, whatever may be the operating system, there are certain functions, common functions of every operating system, out of which one of them is the memory management, second one is the processor management, third one is the file management, device or resource management, I/O management. The devices come under I/O management only. Secondary storage, file management, security of the system, command interpretation. Not only that, networking, communication, job accounting. You have a log. Once some people are attending the classes, some students are attending the classes, what time they have entered with their login ID, user ID and password, what time they left. So all that comes under, all those come under job accounting. Out of which, in your syllabus, especially in your syllabus, we are going to discuss more about the memory management, file management, process management, processor management, protection and security, device and resource management, and user interface and the command or command interpreter. Let's see these things one by one. Next, we need to know about the memory management. You can see the diagram. The main memory is there and different user jobs are there. Okay, user jobs are there. User jobs will be loaded from the secondary memory to the main memory. At a time, 2 or more jobs cannot be accommodated and executed simultaneously. You may think that the computer operates simultaneously and performs different jobs. Of course, yes, but we can never notice the difference in the change over time. That is why we say simultaneously it is working on in a second, maybe hundreds of jobs, thousands of jobs, it can process and execute and give us the result. You cannot imagine the time. That is how the data or jobs will be executed in a system. What it does under the memory management, there is something called swapping. That swapping is like one job is there which is active, will be brought into memory, which is active. There will be one more job in the main memory called inactive. Okay, inactive. Just now it has finished its activity, and after finishing that, it is not working. It becomes inactive, or it's also called a sleeping process. Sleeping process. So it has to throw out of the main memory. That sleeping process should be sent out of the main memory so as to accommodate the other job to take part actively in the main memory. I mean, active process should be brought into the main memory. Sleeping or inactive process should be sent out of the main memory. You can see the memory is divided into two parts basically in that. Okay, the first part, operating system is stored. In the second part, you have the space for jobs. Job can be a program. Job is a program. Okay, so one job comes in, the other job goes out of the memory. Why is this required? It has to find out which is sleeping process, which is active process. Always these jobs should be sent out, especially the sleeping process. Sleeping job should be sent out of the main memory because another job will be there waiting for execution. To accommodate that job, to store that job, it should free this main memory place or space. That is why this process is going to be completed by the operating system, performed by the operating system. We call that as swapping process. Swap in, swap out. Inactive process will be sent out of the memory. Active process will be brought from the secondary memory to main memory. This process is called the device and memory management by the operating system. This is the main function of the operating system. What it does, it allocates the memory space for the job and it will free the memory space once it is done. It will reallocate if it is not completed. It has to come back. So it will allocate some time span for each jobs. Depends on the type of operating system. You will come to that later. So time span will be given. So in that time span only, it has to complete the job. If it cannot complete the job within that stipulated time span, then it has to be sent out and then it has to be brought back to the reallocation of the memory space. When the block is freed, it has to reallocate and then it has to keep track of the memory usage in the main memory. Okay, it has to keep track. This is exclusively with the main memory or random access memory. Next to process management. We have n number of jobs to be executed. Just now I told you it has to allocate, reallocate, deallocate memory space for different jobs, isn't it? In the main memory, different jobs are there. It has to find out which job is ready for execution, and the processor time will be allocated to that particular job. Once that job is completed, another job will be waiting. You can see the diagram there. Another job will be waiting to enter, to make use of the processor for execution. Once that is completed, maybe the first job itself, which was not completed, which was incomplete, should be brought back and allocated the processor timing for that. So this particular type of operations will be performed by processor management or process management. Different files will be there to be shared by different jobs. It has to keep that all these things come under the processor management or process management. There is something called schedule process. In that schedule process, it has to find out what type of scheduling algorithm it has to perform. First come, first served. Processor will be given the time, the one which is there in the queue, the job which is there in the queue. In the front of the queue will be allocated the processor time. It has to perform the job. It has to complete the program. It has to complete the execution. And then next job, and then next job. First come, first served basis it will allocate. Otherwise, the operating system will allocate the time span I told you just now. Some time span will be given to each jobs. So during that it has to perform some work. During that time the job can interact with the processor. If not possible to complete during the stipulated time, it will be thrown out. Another job will be brought in. Again the same span of time, same duration of time will be allocated. Maybe in terms of nanoseconds. That is why we don't feel that the computer is working on different jobs. It is working on only my job. That is how we feel, isn't it? Some nanoseconds will be allocated for each job. So that is called scheduling algorithm. Okay. round robin, again it has to come back. These are the few, scheduling algorithms you will have. Maybe to give you a simple example, maid servant will be there in the house. She comes to your house in the morning, maybe 6 o'clock. 6 to 7 o'clock she works in your house. Exactly 7 o'clock she goes to the other place. Suppose she can complete the work in your place, she will not come back. If not, she will come back. In the next round, 6 to 7, 7 to 8, 8 to 9, 9 to 10, again come back to your house for completing the work. She will continue like that. That's called round robin. Operating system does the same type of activity in the case of the processor management or process management generally. Next, about the device management. You can see different devices connected to the system. Mouse is a device. Keyboard is a device. Printer is a device. Okay. Plotter is a device. Monitor is a device. Speaker is a device. Or can be any other devices connected to the system. Suppose it is in the single user environment. Not a problem. All the devices are allocated to that user only. Whenever the request comes from the user to make use of that device, operating system allocates that device and it will complete the work. Say for example, I want to take 100 pages of printout. I'll give a request through some of the software. Through that I'll give the output for printing. It sends, it will allocate the printer. Of course it is available, readily available. It will allocate the printer and give it to me. In case it is in a multi-user environment, more people are there using the same computer with the same operating system, using the same device connected to one computer. Maybe n number of users will be there. In that case, how does it allocate? It has to find out two different things are there, aspects are there. The operating system has to work on two main aspects. One, shareable device or resource. Two, non-shareable device or resource. Especially this happens in the multi-user environment. Many people have requested for the printer. Printer is not a shareable resource. Somebody is using that printer. Another set of jobs for printing will be sent in a queue, and it has to start the new work only after the earlier work is completed. It takes the next job until it completes that particular job. It cannot allocate that device to the other job. Like that it continues. Non-shareable device. Non-shareable resource. But shareable resource can be your modem. N number of people will be there in the browsing center, but only one modem is there. All of them are using it for internet access. Only one modem. All of them are using. Simultaneously they can use it. That's a shareable resource. So it has to find out which resource is available and to which job it has to be allocated. It is the job of the operating system under device management. Next, under file management, you can see two different diagrams I have given there. Okay, under disk operating system or DOS environment, MS-DOS, I told you, it's one of the character-based operating system. It has to create the files and directories. Those directories are called folders in the Windows environment. When you create a folder, it has to give the link. When you store some files in that, it has to give the link, and that link should be recorded in some place. That some place is called FAT. FAT is file allocation table. File allocation table. Like you have your notebook, normal notebook. If you turn the first page there, the wrapper page, inside that the very first page will be contents, serial number, topic, page number, some such things will be there. You have to record it as when you attend the classes. And you will come to know at what time, date and time, which topic was conducted. All such details you can come to know with your fingertips by looking at the table of contents. So this operating system job is to give the link to that file allocation table when you create a folder or a directory, when you create a file, okay, and store it in a particular place. So this helps the user in accessing the data or a file whenever he wants or she wants within no time, because those details will be recorded in the file allocation table. Address, starting address, sending address, date, file name, and there are certain other things called attributes. Okay, that is for the security of the file. Those attributes are also recorded with the files, and it has to keep track of all the files stored in the memory, deleted from the memory, even that also it has to keep the record, right? Deleted files, stored files, everything will be there. But once the files are physically removed from the file, from the disk, like for example, when you clean up the recycle bin, physically those data will be removed from the file, so from the hard disk. Okay, till then it will be recorded, it will be present in the file allocation table by the operating system. It has to maintain the tree model. You can see a root directory, subdirectories, under that so many subdirectories, and then files. It's an upside down tree. Okay, it has to maintain that order. It can be Windows environment or any other environment. Even in the Unix operating system also, this type of file maintenance or file system will be maintained. It has to allocate the space for every file stored in the secondary memory. This file management is exclusively for secondary memory. Can be hard disk, can be floppy disk, can be pen drive, can be any other external storage device. Fine. Next, protection and security. What is that protection and security? You need to find out. Suppose you are working in a system. If somebody comes and asks you for something, if you keep it as it is and then if you get inside, there are chances of spoiling the contents or the data or the files from your system, knowingly or unknowingly. Maybe they are not aware of the computer operation. Right? If they press some key there, maybe unfortunately it can be a delete key. If it deletes that file, then you will be in trouble. Or deletes the data, you will be in trouble. In such situations, what do you have to do? You have to lock it and go with the help of a password. To put on the system also you must have a password. For every file system you should have a password. Isn't it? Every file, every directory, you can give the password protection. And that is available in all the operating systems. Okay? This is to provide the basic protection to the files. Next, when we see user interface or the command interpreter, suppose you give a command, that command line interpreter will be there in the operating system. The command given by the user in a particular line, you imagine in that way, that has to be translated into computer understandable form for the execution. Operating system does that job. It works as an interpreter because commands are not given at a stretch. It is there. It is one of the options in the operating system to execute a set of commands at one stretch, because repeatedly same set of commands are executed. We call it as the batch file. Let us not worry about that for the time being. I'll give a command. That command has to be translated into machine language and then it has to be executed in the system. Isn't it? When we are performing all such things, there should be a kind of interface of the translator. We call that as an interface or as an interpreter. Especially with the operating system, it is called command line interface interpreter. the translation has to take place. So there are basically two types of user interfaces. We call it as user interface. One is called the character based or command line user interface. We call it as CUI. Another one is GUI, graphical user interface. Two different interfaces are there to interact with the computer. What are the differences between those two? Let's see now next. CUI, character based interface. Command line interface, user interface. Hundreds of commands will be there. You can see the examples given. Some external commands, internal commands, and some such things. Hundreds of commands will be there. Sometimes thousands of commands depending on the operating system. Unix, hundreds or thousands of commands can be there in one of the operating systems. You need to remember all those commands to operate the computer, to interact with the computer. For our own activities or jobs. Say for example, I need to copy a file from one place to other place. There is a command. To remove a file from the hard disk or from the floppy disk or from any other device, there is a command. To create a folder, there is a command. To remove a folder, there is a command. To see the time and date in a system, there is a command. For everything, you have to depend on the set of commands. And of course, those commands you have to type in from the keyboard and execute it for getting the work done from a system. This is called character user interface or command line user interface. Okay, using command line only you have to type in the command. But what is that command? It's a set of characters again. That is why it is called a character based interface or character user interface. In this, you cannot use the mouse. In the graphical user interface, you can use. In this, you cannot use the mouse. I know you have a question. Why do you want to type in the character? You have the mouse, you can use that to get the work done. You can't use the mouse. And you have to type in the characters. You should remember the commands and then type in the characters to execute it to get the work done from the system. You will have internal commands and external commands like that. So you have to remember those commands. Next, when you say graphical user interface, in that graphical user interface, it is something like what you see is what you get. WYSIWYG, we call it as WYSIWYG. What you see is what you get. You can make use of mouse now. In this, by right clicking on it, you will get the list of commands. You don't need to remember any commands. Right click on it, you will get the list of commands. If you want to get the operations performed by the operating system, you will have a questionnaire. We call it as the dialog box. What do you have to do? Once you give a command, maybe by mistake that command is given, it will ask you a supporting question. Supporting question will be asked by the operating system. Say for example, you delete a file. Are you sure you want to delete a file? That question will be asked. For the sake of security, by mistake if you have deleted the file, you can get it back during the execution of the delete command itself. Such things will be there, and everything will be controlled through the graphical input device called mouse, graphical input device called touchpad, graphical input device called light pen. There are so many. Using such devices, you can operate on the system. You can get the work done from the system. This is actually called the graphical user interface. Most popular and the recent, all the devices, including your mobile phones, you will have this particular user interface. Next, we need to find out the differences in these two. Character user interface and the graphical user interface. Let me tell you about the character user interface. It is not user friendly. You need to remember hundreds of commands, thousands of commands. It's not user friendly. Mouse cannot be used in the operating system, especially in this particular user interface. To interact with this computer, of course, you need to type in the command every time. Graphical user interface, it is totally user friendly. User friendly, and in the sense, by looking at the screen itself, you can do many different operations. Using the mouse pointer, you have the right click, left click, and also the scroll button, middle one. There are many options on the input device, graphical input device called mouse. Using that itself, you can have the access to all the commands present in the operating system, in the graphical user interface. Okay, these are the few differences between the character user interface and the graphical user interface. Character user interface is not WYSIWYG, but the graphical user interface is WYSIWYG. There is nothing. What you see is what you get. In character user interface, suppose you have incorporated some special effects to the text. Okay, the text only after getting the printout you will come to know the special effects. On the screen you cannot see. That is why it is called not WYSIWYG. But when you use graphical user interface, what you see is what you get in the printer. Okay, so this is about the character user interface and the graphical user interface. Next one, I was telling you about the different types of operating system. Okay, different types of operating system. Only one person is using a computer. The whole and sole responsibility is of that person only. Entire activity will be for him only, it is allocated for him only. All the resources are his only, or that user's only. Any operation he is performing, operations he is performing, jobs he is executing, programs which he is executing, memory, hard disk, everything is his property only. Single user. Single user. Only one person is using the computer. Okay? Only one person is using the computer, but all the resources are for him only, alone. And the operating system responds to him only, alone. To that user alone. Batch processing. Batch operating system. I'll explain those things one by one later. Multi-programming. Many different programs can be executed at the same time. Can be a single user operating system. Multi-programming is many programs can be simultaneously executed. Multi-programming. Multitasking. Different jobs at the same time. You're taking the printout here, you're downloading something here, you're operating the keyboard, you're using the mouse. Multitasking. Multi-user. A same computer. Many users are there for the same computer with their input and output devices alone. Okay, maybe monitor and the keyboard mouse, monitor, keyboard and the mouse. Sometimes you will have the processor also. Let's see what are those types later. Time sharing operating system, I told you already. It will allocate the time span for each user to get the complete job from that set of users. It will allocate some job timings. It will execute the program. If not possible, it goes to the next user. If not possible, it goes to the next user. Some time span will be given to each user to get the work done from the computer. Real-time operating system. I'll give you an example for those things later. Distributed operating system, network operating system, and multi-threading operating system. So these are the few types of operating systems. Till here, whatever we have learnt, the questionnaire will be there. In that questions, you will have varieties of questions like 1 mark, 2 marks, 3 marks and 5 marks questions. In the next session, you have to answer to those questions and keep the things in your fingertips. Thank you.